In real data engineering projects, files don't arrive only once. New files keep landing every hour, every day, or sometimes even every minute. And if you manually read the folder again and again, a few things may go wrong. You may reprocess old files, you may miss new files, you may create duplicate records, or your browse layer may become messy very quickly. And this is exactly where Databricks Auto Loader helps. In this video, I will explain what Auto Loader is, why normal spark.read is not enough for recurring file ingestion, and how Auto Loader helps us incrementally load new files into bronze layer. Hello everyone, welcome to Big Data Fact. I am Pranit and I have 4+ years of experience working as a data engineer. If this is your first time visiting this channel, don't forget to subscribe for more content on big data and real world insights. Now let's understand the problem first. Let's say we are building a Clickstream pipeline. Every few minutes, new JSON files are landing in cloud storage. Maybe these files are coming from an app or a website, Kafka downstream, or some event collection system. Now a beginner might write something like this. And this is fine if you're reading data only one time. But in production, data does not arrive one time. Data keeps arriving. So now the question becomes, how do I know which files are already processed? How do I process only the new files? How do I avoid the same file reading again? How do I load this safely into bronze layer? This is the ingestion problem Autoloader solves. Normal spark.read is a batch read. Autoloader is designed for incremental file ingestion. Databricks describe Autoloader as a feature that incrementally and efficiently process new data files as they arrive in cloud storage using a structured streaming source called cloudFiles. So what is Autoloader in simple terms? Autoloader watches a cloud storage location. When new files arrive, it detects them. Then it loads those files into our target table. And most importantly, it tracks what it has already processed. So instead of you manually maintaining a list of processed files, Autoloader handles incremental file discovery for you. The basic flow looks like this. Raw files land in cloud storage. Autoloader detects new files. Autoloader reads them using cloudFiles. Then it writes them into a bronze delta table. So remember this line, Autoloader is not your transformation logic. Autoloader is your ingestion pattern. It helps you move new raw files into bronze safely and incrementally. Now where does this fit in Medallion Architecture? If you watched my Medallion Architecture video, you already know the flow. Bronze, silver, gold. Bronze is the raw landing layer. Silver is where we clean and validate data. Gold is where we create business-ready outputs. Autoloader usually helps with the raw to bronze step. So the flow becomes raw files in cloud storage, Autoloader, bronze delta table, then silver transformations, then gold metrics. That is why Autoloader is so useful in Databricks pipeline. It solves the first production problem. How do we ingest files continuously without manually tracking every file? Now let's look at the demo. I will keep this simple. We will simulate Clickstream JSON files landing in raw folder. The Autoloader will ingest those files into a bronze table. The source folder will look like this, and the target will be bronze Clickstream. The important thing I want you to observe is not just the code. The important thing is the behavior. So in the first run, Autoloader loads the available files. Then we add a new file. In the next run, Autoloader should process only the new file. This is the main concept. Now let's look at the core Autoloader code. Let's understand this line by line. readStream means we are using Spark structured streaming style ingestion. But don't get confused. This does not always mean we need a never-ending streaming job. We can also run this in a batch-like way using triggers. Now this line is important. This tells Databricks that we are using Autoloader. Then this line tells Autoloader that the incoming files are JSON files. If your files are CSV or Parquet, this option changes accordingly. Now this line is very important. This is where Autoloader stores schema information. Databricks documentation explains that specifying cloudfiles.schema location enables schema interference and schema evolution. And this location can never be the same directory used for checkpoints in some setups. Then finally, .load of raw path. This is the raw folder where new files are landing. Now after reading, we write to the bronze table. Here we are writing the output in delta format. The checkpoint location is very important. Checkpointing helps the streaming job track progress and process its records. Databricks explains that checkpoints track information that identifies the query, including state and processor records. If the job runs again, it does not behave like a fresh job unless you delete or change the checkpoint location. And this line means process the available data now and then stop. This is very useful when you want an incremental ingestion behavior, but you don't want a continuously running stream. Now let's say we run this for the first time. At this point, the raw folder has file1.json and file2.json. Autoloader processes these files and write them to branch Clickstream. Now if I run select star from branch Clickstream, I should see records from those files. And because this is branch, I may also add ingestion metadata like current timestamp. This is useful because I can know when the record entered my pipeline. So at this stage, the branch table is not cleaned business data. It is raw ingested data with some useful metadata. This is the responsibility of branch. Now comes the most important part. Let's say we have a new file arrives. Now the raw folder has file1, file2 and file3. But file1 and file2 were already processed earlier. So when autoloader runs again with the same checkpoint, it should process only the new file. That is the key behavior. It should not reload everything from scratch. It should not duplicate old data. It should only pick up the new file and append it to the branch table. That is why autoloader is useful for production ingestion. It removes the need to manually ask which files were already processed, which files are new, which files should I skip. Autoloader takes care of incremental file discovery and progress tracking. Now let's talk briefly about schema evolution. In real projects, source file change. Today, your JSON may have event ID, user ID, event type, and event time. Tomorrow, the source may add device, country, campaign ID. If your ingestion pipeline is not designed properly, this can break your job, or silently, it can create messy data. Autoloader helps with schema interference and schema evaluation when cloudfiles.schema location is configured. But here is one important point. Schema evolution does not mean you stop caring about schema. You still need monitoring. You still need validation. You still need to understand whether the new column is expected or not. So for this video, remember only this. Autoloader can help manage changing file schemas better than a manual ingestion approach. But production teams should still control and monitor schema changes. Now when should you use autoloader? Use autoloader when file keeps arriving continuously or repeatedly. Use it when you are ingesting from a cloud storage. Use it when you want to build a branch table. Use it when file volume is growing. Use it when you need checkpoint-based progress tracking. Use it when you don't want to manually track processed files. But don't overcomplicate everything. If you're doing a one-time small local file read, spark.read is enough. Autoloader shines when ingestion is recurring, incremental, or production-like. So the simple rule is one-time read, spark.read, recurring file ingestion, autoloader. Now let's convert this into an interview-style answer. If someone asks you, what is Databricks Auto Loader? You can say this. Autoloader is Databricks incremental file ingestion feature. It uses the cloudFiles structured streaming source to detect and process new files arriving in cloud storage. It is commonly used to load raw data into branch delta tables in Medallion Architecture. Autoloader tracks progress using checkpoints and supports schema evaluation and schema interference using a schema location. That is a strong answer. Because you are not just saying autoloader loads files, you are explaining what problem it solves, where it fits, how it tracks progress, and why it matters in production ingestion. So let's quickly recap. Normal spark.read is good for one-time reads. Autoloader is useful when files keep arriving. It uses cloudFiles. It tracks progress using checkpoints. It can help with schema interference and schema evaluation, and it's commonly used to ingest raw files into a branch layer. The main takeaway is this. Autoloader helps you build incremental production-style file ingestion into Databricks. In the next Databricks video, I can cover either schema evaluation in autoloader or delta merge for retry safe loads. Comment autoloader if you want more Databricks videos like this. If this helped, drop a like and subscribe to Big Data Factory. This is all for today. I will see you in the next video. Till then, keep learning and keep building. Bye bye.